Spanning tree protocol PortFast is great. It speeds up convergence, so a lot of people use it. But it has one big negative. It can cause a forwarding loop. This video will talk about the great advantages and that one big concern about that forwarding loop. Let's take a look. Now this video is a little different than some of the other ones. Normally I follow the structure and outline of the books, but in this case I cover PortFast in two different chapters, the concepts in chapter 9 and the configuration in chapter 10 of the now current book that covers PortFast, the volume 1 of the CCNA official cert guide. So what I've done for this video though is that I want to cover all of PortFast in one video. So I've taken the concepts from chapter 9 and the implementation details in chapter 10, and I'm just doing one video on all of it. So in this video, I'll talk about the concepts first. Then in the next section, how to configure with interface subcommands. It's the most straightforward way to configure. Then I'll fold in a discussion of a global configuration and how that impacts the configuration of PortFast on access ports. Then I'll talk about configuring PortFast on ports that use trunking. It's a little bit of a mix of conceptual and config information. And then finally, I'll talk about that loop danger, forwarding loop danger, and how do you deal with that. As always, if you stick around to the end of the video, we'll talk about things as if you're in the same study group as me. I'll give you advice about where to focus your study after you finish this video. In particular, I'll point you to a review exercise. It's right here at the YouTube channel, and I'll mention some things over in the book. So if you have the book, you can dig in and learn more about PortFast. All right, let's jump in and talk about it. First, for a few details about protocols. Spanning tree protocol was first defined in the 802.1d standard that first published back in 1990. And then 10, 11 years later, somewhere around the turn of the century, 802.1w as an addenda was added to 802.1d, and it defined rapid spanning tree protocol. And that's where the idea of PortFast was first standardized, all right? Then later, about 10 years after that, all of that detail was moved over to the 802.1q standard. So if you want to read about it today from the IEEE, you'd want to find the 802.1q standard. But what happened in between here in real life was that Cisco said, hey, spanning tree protocol convergence isn't great. Let's change some things for how Cisco implements spanning tree. And they added this feature called PortFast. So it predated the 802.1w rapid spanning tree protocol by several years. So when we talk about PortFast, that's Cisco's original term for its pre-standard feature. And what the IEEE implemented was basically the same thing, all right? But a lot of us just refer to it as PortFast because of that original timing. So what is it? Well, if we think about spanning tree before you add PortFast to it, and we think about a port that's connected to an endpoint device, you've got the switch sending hello messages and the endpoint ignoring them and not sending any because the endpoint isn't participating in spanning tree. So what happens on the switch is the port comes up, it's going to choose to become a designated port. It's going to choose for that port to be in a forwarding state, but because it's spanning tree, it doesn't immediately place the port in a forwarding state. It first goes through a listening state for 15 seconds by default, and then a learning state for 15 seconds by default, and only then does it reach a forwarding state. So the time from when it chooses to become a designated port until it places the port in a forwarding state is 30 seconds. So that's the slow part of spanning tree without PortFast. So spanning tree on a port with PortFast or RSTP as implemented with PortFast. Remember, the PortFast term is the Cisco term, but that's the term that most often we'll see out there in the wild. Here's what happens. The port comes up. Spanning tree decides to make that port a designated port. So none of this waiting stuff. Immediately it's placed into a forwarding state. It's sub-second. So not a 30-second wait, less than 1 second wait to reach a forwarding state. So let's focus on the lingo for a moment. 802.1w RSTP refers to this feature as edge ports, whereas Cisco refers to it as PortFast. It's the same feature. And this feature refers to what to do to speed things up on ports connected to endpoints. So these ports down here, not those ports connected to other switches. In fact, it's dangerous to use it on ports connected to other switches, and you get big warning messages when you configure it, and we'll see those here in this presentation. So what happens on these edge ports is the port's going to stabilize as a designated port role and in a forwarding state anyway, and it's just speeding up the process of making that choice. But you and I as a network engineer would have to observe which ports really are connected to endpoints and then identify those via configuration, all right? And I've got a PF here just to signify that we've configured something that enables PortFast on those ports. Now, lingo again, PortFast is the Cisco term, whereas point-to-point edge is the term from the 802.1W standard, all right? Now, where are you going to see those terms? In config commands, it's pretty much always going to be PortFast rather than the 802.1W edge terminology. Not always, but for the most part. And then in show commands, it's almost always PortFast, but occasionally you'll see this point-to-point edge term show up. So I'm going to give you plenty of examples of config and show commands so you can see where those show up and get used to that. So now we get to the core of the feature. So what's the logic on a port where PortFast is enabled? Well, it basically suspends normal STP logic on that port. And it immediately then uses that designated port role and forwarding state. So, hey, you've got PortFast enabled, poof, designated, forwarding, no wait. Now, that's good, but it's also dangerous, all right? So first off, it goes straight to those roles and states, or that role and that state. It still sends BPDUs, but it shouldn't be receiving any BPDUs. That's the idea. The engineer looks at the topology and says, those are endpoints out there. They're not going to send me any BPDUs, but that's the danger. So if BPDUs are received, PortFast will react. It'll say, hey, I shouldn't have gotten that. I'm going to react. I'm going to revert back to normal STP operation and converge. But there's timing going on in there between when that first BPDU is received and it says, oh, that's not right. Let me converge. And during that short period of a second or two while it's deciding, should I block on this port, there could be temporary loops happening. All right, and I'm going to explore that a little bit more fully here as we go through the video, but that's the danger. All right, so those are the main features. Just a quick overview of what you'll see to see evidence of this. Remember the terms PortFast and point-to-point edge or edge will show up. Well, this show command that shows spanning tree referring to an interface does refer to the point-to-point edge term, which is the 802.1W term to refer to this feature, whereas show spanning tree interface with the detail option refers to the feature with the term PortFast. Go figure, right? Then down here in show interfaces, without the word spanning tree, which is about interfaces rather than spanning tree operation, there's no mention whatsoever down here about whether PortFast is being used or not. All right, so keep an eye out for the term edge and the term PortFast to see whether this feature is enabled on an interface. Next, let me walk you through the straightforward interface subcommand way to configure PortFast. Now, we only want to use this on access ports, that is, ports that are connected to endpoint devices. So these down here, and again, those ports are going to land in a designated port role and in a forwarding state at the end of this. It'll just happen quicker with PortFast enabled. So how do you enable it? You get into interface config mode on any and all of those ports and configure spanning tree space PortFast. There you go, it's enabled. Now what's interesting is you get this long response message that talks to you about the danger, and you should pause and read this message at some point. But it talks about how you can have temporary bridging loops or forwarding loops, and it tells you use with caution. So that's part of the point of this video, is to help to make sure you understand what's going on. Another thing it mentions is that this command enables PortFast, but it will only have effect when the interface is in a non-trunking mode. So this command enables PortFast on this interface if it is currently operating as an access port. And if it happens to be operating as a trunk, it does not enable PortFast. All right, so there you go. Enables PortFast if it's an access port. There you go. That's it for the config. So here we go. Interface whatever, spanning tree PortFast enables it. If you want to disable it, do the same command again, but give it a no in front. No, spanning tree PortFast disables it again. If you want to confirm that it's configured, it's like those same show commands I showed you just a few moments ago. Show spanning tree referring to the interface. It's going to give you a type out here on the far right that says PTP edge. That's for point-to-point edge. So links that are just between two switches are point-to-point. Links that are from a switch to an endpoint where PortFast is enabled, point-to-point edge, that's per the 802.1W standard. Whereas this different command, show spanning tree interface, refers to the interface ID, but with the detail keyword, that's the extra part compared to this command, with the detail keyword, it has a reference to the Cisco term PortFast. And in this case, that PortFast mode phrasing means that it's configured with that interface subcommand. And coming up, I'm going to use a global command, and it'll have a little different phrasing out here that's a clue to the fact that you've configured a little differently. In this next section, I'm just covering the rest of the PortFast configuration, all right? So imagine you've got this switch and it's got 24 ports that are connected to endpoints and you want to enable PortFast on all of them. Well, you could use that interface subcommand config that we just saw and configure that on all 24 ports and you're good to go. If that's your preference, you're done. But to learn for CCNA, let's talk about an alternative. You can use a global command that basically sets the default setting for all these ports, and the default can be to enable PortFast, all right? So if you configure this global command, notice we're in global config mode here, spanning tree PortFast default, it says, hey, the default on access ports is now to use PortFast. So that's a pretty common thing to do as well. So the idea would be, hey, you've got all these access switches on the ports that are trunking. They won't even attempt to use PortFast. On the ones that aren't trunking, those are the ones connected to endpoints anyway, so let's use PortFast. So that's what this command does for us. It does give us the usual disclaimer about creating temporary bridging loops, which is typical. So if you did that and only that command, any port that's up and working that's an access port will have PortFast enabled on it. If that's what you want, you're done. Now, it could be you say, hey, of those 24 ports, there's one of them I don't want to use PortFast on. So you could use this global command and then reverse to not use PortFast on that one port. So you get into interface config mode on that port and use the spanning tree PortFast disable command, which disables PortFast on that one port. And the other 23 in this case would be using PortFast. Now, as a bit of trivia, remember that show spanning tree interface command with the detail keyword? Well, it turns out if you did this command first on an interface where PortFast is enabled because of that global command, and then on one where it's enabled with an interface subcommand, you're going to get different output. So up at the top is the one where it's enabled per the interface subcommand. The output says the port is in the PortFast mode, and the one that's enabled for the global command says the port is in the PortFast mode by default. And that extra by default bit out here is the clue that it's because of that global command we just saw that it's configured. Bit of trivia, but just to point it out in case, say, you came across an exam question that showed this output instead of this. Now there's one other configuration variation I need to go over with you. First off, let me just say right up front, never enable PortFast on a port connected to other switches, all right? But we're going to talk about enabling PortFast on trunk ports, but it's not trunks to other switches like you're used to thinking about. It's trunks to servers. So it's pretty common to use VLAN trunking on ports connected to servers this day and age. So I've got a couple of servers in the pictures there. So yes, that's where you would consider enabling PortFast when you're using trunking on a link to a server. So that's what we're talking about here. You don't use it up there on those links to other switches. You could create a forwarding loop and that's bad. And we're also not talking about these links to a phone that's then connected to a PC. Those you'd actually configure just like you would if it was only a PC out there, as we've talked about for the last few minutes here in this video, all right? So not there. It's just you got a server connected to a port, you're using trunking, you've got to configure PortFast a little differently to get it enabled, all right? So what's the difference? Interface subcommand spanning tree PortFast, if you stopped there, that would enable PortFast if it was an access port. Spanning tree PortFast trunk enables PortFast if it's a trunk port. If it's operating as a trunk, there you go. Now you've enabled PortFast on that trunk that's connected to a server. So the downside of using PortFast is it can create those forwarding loops. You get the big warning message when you enable it. So what's the real danger here? Well, first off, the danger would only occur if someone goes out there and takes that single device that's connected to the port and replaces it with a switch. But even then, it's not always a danger. For instance, let's just say somebody unplugged that PC and they put in some switch they bought at the store, like B1 here. Well, there's no physical loop existing out here. So if that happened and we had PortFast enabled on A1 switch ports, there's no physical loop. There's no way for frames to loop around. That's actually not a concern. And then even if we replace both of those PCs with switches, but they're not connected together, again, there's no way for frames to loop around out here. But if we replace both of those PCs with switches and somebody got cute and connected them together, then there's actually a path for frames to loop around. And depending on the timing of when these were connected and then how quickly PortFast said, hey, I've got a BPDU, let me reconverge with spanning tree and decide which ports really need to block and get them to a blocking state, you might have 1 or 2 or 3 or 4 seconds with this looping environment. And you might literally have millions of frames released into your LAN that are just extra frames getting looped around, all right? So while it's not the end of the world, it's a lot of extra traffic going around in the network. There's no mechanism to remove them, all right? So it's not good to have that temporary loop. It's better to not have that. So we want to consider whether there might be a better way to deal with this, all right? But PortFast, it will react. It'll notice incoming BPDUs. It will go back to just using plain old spanning tree. So the first protection for PortFast is PortFast's native operation. So just with PortFast, if it gets that BPDU, it'll revert to using normal STP, RSTP logic. It'll say, hey, should this port be a designated port? No, it shouldn't. It has no role. I should block. It'll move it to a blocking state. It'll stop the loop and we'll get back to normal. And that may be good enough, all right? However, the most popular thing to do is to combine PortFast with this feature called BPDU Guard, and that'll be the next video in sequence for instructional videos, which says if that same scenario happens when that unexpected BPDU arrives, we're going to disable the port. In that way, the engineer will notice, hey, the port's down, and they'll go look into it, and they'll find out somebody unplugged a PC and plugged in a switch or 2 or 3 that they weren't supposed to. Hey, folks, don't do that. If you need more ports, let us know. We'll accommodate you. But that causes problems for the network if you do that, and you can deal with it in a professional way. All right, so that's the best combination. Now, Cisco added what is yet another way to help PortFast with this thing called BPDU filter. I wish they hadn't added it to the blueprint this latest time around, but it's another thing that really reacts almost identically to the native PortFast mechanism. If a BPDU arrives, it dynamically disables PortFast. It uses STP and RSTP logic. It's just a slightly different in terms of what hello messages are sent, the timing for those, how many of them are sent. I'll have a video for that as well, but mostly it's a pain in the neck for exam takers, honestly, at least in my humble opinion. All right. Now, there are a couple of other topics that are minor spanning tree topics that we will get to, but just to point out that the other 2 have nothing to do with PortFast. So loop guard and root guard that we'll get to don't have anything to do with PortFast. So when you think of PortFast and its ways to be helped and protected, think of PortFast teaming up with BPDU guard and possibly BPDU filter. So the ones with BPDU in the names are the ones that team up with PortFast. All right, it's study group time. Where should you focus? What's most important out of what we just talked about PortFast? Well, first off, concepts are greater than config in this case, so just make sure you've got the idea of the big concepts with PortFast. The minutia and those show commands in particular, I'm a lot less worried about. You also want to understand that danger of loops, when it can be an issue, when it really isn't an issue, and for how long. That discussion that was at the end of the video, that's also pretty important. Now, you can practice that with the next video. It's an interview review video, so I'll pose a few questions to you in the context of the drawing you see there on the slide. And the interview review video asks you questions like where to use PortFast in the context of this new figure, what are the risks to using it, what would have to change in this topology for there to actually be a loop, and I'll even give you a sample config and let you review it and say, hey, where has PortFast been enabled and where has it not been enabled based on that sample config to get you into that. Additionally, as always with the books, using the books as another source beyond what you see in the video is great. It's just a proven benefit. If you use 2 different sources, maybe even 3 sometimes, it'll help you remember and help you deepen your knowledge of the topic. So take advantage of that chapter 9 and 10 in the current edition of the Volume 1 book for topics on PortFast. Hope you enjoyed this video on PortFast. If you're ready for the next topic, it's BPDU guard. You can click on the left and get to the instructional video on that. But if you're ready for that interview review exercise, it's the video over on the right. Hey, hope you enjoyed it. We'll talk to you soon.